We've seen an example of the Cox proportional hazards model where we looked at patient variables like whether they're a smoker and what their age is. And we multiplied each of these variables by a weight. So we can come up with a more general form of this expression where we can call these betas. So this is beta 1 and this is beta 2. And we can call these x's. So there's x1 and x2. Now, of course, a patient might have more than two variables. And so the more general form of this expression is lambda t is lambda naught of t times exp of beta 1 x1 plus beta 2 x2, so on and so forth. And we can simplify that to say it's the sum over I of beta I xi. And of course, we have our lambda naught of t term. So let's continue from there. So now we've also seen factor increases in the risk by a unit increase in the variables. So we saw that if we have a variable xi, then if we look at the weight associated with it, bi, and we take the exponent of that weight, then that represents the factor risk increase when we have xi become xi plus 1. So it tells us what the increase is in the factor risk when we have a unit increase in our variable. And we saw two examples of this with age and with smoker, where increasing smoker from 0 to 1 increased the risk by a factor of 1.08, and increasing the age from any age n to n plus 1 increased the factor risk by 1.01. And so one thing worth noticing here is that when our exponent of bi is greater than 1, that means the risk factor increases. But when our exponent of bi is smaller than 1, that means our factor risk decreases. And so if we have this going on, it means our variable xi is actually reducing risk. So let's look at that with an example. So here we have an example where we have four patient variables: age, their HDL cholesterol, and don't worry too much about what this means, whether they had treatment, and whether they are a smoker. And so we have our Cox proportional hazards model with the following weight attached to these variables. Now we can take the exponent of those weights to get the factor risk increase associated with that variable. So we can see that increasing age from, let's say, 50 to 51, or whatever unit increase this can be, so this can be increasing age from 2 to 3, would increase the risk by a factor of 1.14. And just to put that down, if someone is 51 and we looked at their risk at any time t, it would be lambda of 50 at time t times the factor of 1.14. And now we can see that for HDL, we have a negative weight, and when we take the exponent of that, the result is smaller than 1, so this is actually decreasing risk. For treatment, we see the same thing where our weight is negative, and so our x of that weight is going to be smaller than 1. Therefore, having treatment or having a high HDL is actually reducing the risk for that patient. Finally, we have a smoker, which, like we've seen before, has a positive weight associated with it, so it's increasing the risk by this factor amount.